Digging a little deeper into the periodic table of element while looking at the relative atomic mass and the isotopes. You've probably heard of the atomic mass being the mass of an atom or a certain quantity of atoms, such as a mole of atoms, in grams. The relative atomic mass is when you compare the mass of the atom to carbon 12. Why carbon 12? Well, it is the most common element on our planet. Its unit of measurement is the atomic mass unit, or otherwise known as the AMU. Please realize that 1 AMU is actually 1/12 of the mass of a single atom of carbon 12. The relative atomic mass of carbon is actually 12.011 AMU because on Earth we also find some carbon 13 and some carbon 14. Now, the atomic mass number is found by rounding the value of the relative atomic mass. The atomic mass number represents the quantity of nucleons found in the nucleus. Nucleons are actually the combination of protons and neutrons together, and of course, are found in the nucleus. To find the number of neutrons in an atom, we need to subtract the atomic number from the atomic mass number. Here's an example with carbon. The atomic mass being 12.011 AMU, we would round it to 12. The atomic number of carbon being 6, we need to do 12 minus 6 in order to find 6 neutrons in the carbon atom. Now that we know that an atom has actually three subatomic particles, the neutron and the protons that are found in the nucleus, and the electrons that are orbiting around the nucleus, we can represent an atom with the simplified model, where we would first draw a circle that would include the symbol, such as chlorine, and include the number of protons and neutrons. So in chlorine, there are 17 protons, as it is its atomic number. There are 18 neutrons, and this is the distribution of the electrons on each of the electron shells. 2 on the first shell, 8 on the second, and 7 on the third. In order for two atoms to be considered to be the same element, they absolutely have to have the same number of protons. Yet, they could be varying in number of neutrons, and this is what we call isotopes. Isotopes of an element are more or less abundant in nature. For example, the isotopes of oxygen come in with 8 neutrons, 9 neutrons, or 10 neutrons. Of course, the oxygen 16 is the most abundantly found on the planet, but we can also find some oxygen 17 as well as some oxygen 18. We've been able to calculate the atomic mass of an element with the help of the isotopes. We add the average of the mass of all the isotopes of an element that is multiplied by the relative abundance of that isotope in nature. Let's have a look at this example of oxygen, which has three isotopes: oxygen 16, oxygen 17, and oxygen 18. So the atomic mass number of each three is 16, 17, and 18, respectively, When we multiply this number with the relative abundance, and as we can see, oxygen 16 is the most abundant at 99.76% on our planet, we actually get these value for an average mass. And when we add it all together, this becomes the recognized mass of an atom of oxygen. Just in case you're wondering how I reached those numbers, you need to remember that 99.76% actually is 99.76 divided by 100. So this number would actually become 0.9976. And if you multiply that by 16, this is how you'll reach 15.96. And you do the same for the two other numbers to reach the final answer of 16.0044. Some known isotopes are rather unstable and will spontaneously transform into a more stable atom. We would call those radioactive isotopes or radioisotopes. They have had several applications since they were discovered by the physicist Henry Becquerel in 1896. Here are a few applications. For example, cobalt 60 is used in radiation therapy to prevent cancer. Iodine 131 locates brain tumors and monitor organs. Carbon 14 has been used to date prehistoric dating and medicine. Carbon 11 is used in PET scans, and thallium 201 helps analyze damaged heart tissues. So, in summary, you've just seen how we calculate the relative atomic mass of an element as it is compared to carbon 12. The atomic mass number is actually the rounded value of the relative atomic mass. The number of neutrons in an element is calculated by subtracting the atomic number from the atomic mass number. The simplified model of an atom includes the number of neutrons and protons inside the nucleus, along with the symbol of the element, and the layers with the different number of electrons that they contain. Isotopes of an element have the same number of protons but may differ in number of neutrons, therefore granting them varying masses. The atomic mass is therefore calculated using the mass and abundance of each of the isotope of an element. Some isotopes have unstable nucleus, which makes them radioactive. Therefore, we will call them radioisotopes or radioactive isotopes.